Welcome to Math Tutorials. In this video, we are solving every question of exercise 5.6 of Chapter 5, Continuity and Differentiability, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 5.6 has 11 questions on parametric differentiation. dy by dx computed as the ratio of the two parameter derivatives, without ever eliminating the parameter, ending with a proof that a symmetric pair satisfies dy by dx equals minus y over x. Here they are. Question 1. Both x and y are powers of the parameter t. The rule is dy by dt over dx by dt. No elimination allowed. We differentiate each equation with respect to t. Differentiate both with respect to t. Divide, the 4t cancels, leaving t squared. Question 2. Both coordinates carry the same cosine, scaled by different constants. The signs will cancel entirely. Differentiate with respect to theta. The ratio is the constant b over a. Question 3. Sine against cosine of the double angle. The double angle identity collapses the quotient beautifully. Differentiate, cosine t below minus 2 sine 2t above. Write sine 2t as 2 sine t cosine t. The cosine cancels. Question 4. A line in t against a reciprocal. Short and sweet. Differentiate both. Divide. Question 5. Differences of single and double angle terms in both coordinates. Differentiate term by term and present the ratio. Derivatives with respect to theta, watching the factor 2 from the double angles. The quotient is the answer, kept in terms of theta. Question 6. The cycloid equations, theta minus sine below, 1 plus cosine above. Half-angle identities will compress the quotient. Differentiate both coordinates. Switch to half-angles. Sine is 2 sine half cosine half, and 1 minus cosine is 2 sine squared half. Question 7. Cubes of sine and cosine over the same square root of cosine 2t, the heaviest quotient of the set. Triple angle identities will collapse both derivatives. Quotient rule on x. The numerator combines to 3 sine squared cosine times cosine 2t, plus sine cubed times sine 2t over cosine 2t to the 3 halves. Factor sine squared cosine. The bracket becomes 3 minus 4 sine squared, which is exactly sine 3t over sine t. The identical computation on y gives minus sine cosine times cosine 3t, using 4 cosine squared minus 3. Divide, the roots and the sine cosine factors cancel, leaving minus cotangent 3t. Question 8. A logarithm of a half-angle tangent joins the cosine in x. The log term differentiates to exactly 1 over sine t. The log of tangent half t gives 1 over tangent times secant squared times a half, which is 1 over 2 sine half cosine half, 1 over sine t. So dx by dt combines over sine t into a cosine squared. With dy by dt equal to a cosine t, the quotient is tangent t. Question 9. Secant and tangent with separate constants. Their derivatives share a factor of secant. Differentiate, a secant tangent below, b secant squared above. Cancel 1 secant and convert to sines, b over a sine theta. Question 10. The involute of a circle. Products of theta with sine and cosine inside both brackets. Product rules create cancellations in both derivatives. In dx by d theta, minus sine cancels against the product rule's sine, leaving a theta cosine theta. In dy by d theta, the cosines cancel, leaving a theta sine theta. Divide tangent theta. Question 11, the last one. Square roots of a raised to inverse sine and inverse cosine of t. Logarithms expose the exponents, and the inverse trig derivatives are negatives of each other. Take logs. Log x is half inverse sine t log a. Log y is half inverse cosine t log a. Differentiate with respect to t. The inverse sine gives the positive root fraction, the inverse cosine the negative. Divide dy by dt by dx by dt. The matching fractions cancel, leaving exactly minus y over x. That completes all 11 questions of exercise 5.6. In the next video, we will take up exercise 5.7 on second-order derivatives. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.